Hi everyone, in this video we're going to be talking about the law of cosines. So this follows directly after learning about the law of sines, which was in the previous video. So we were talking about oblique triangles. Those are triangles that are not right triangles, and solving them. That means finding all three angle values, all three side length measures. So the law of sines deals with cases 1 and 2. In cases 1 and 2, where if you were given one side and two angles, or two sides and one angle that was not the included angle between the sides. So law of sines is used for those two cases. Now we're going to move on to law of cosines, which is for cases 3 and 4. So that's if you're given two sides and then the included angle, so the angle between the two sides, or just all three sides and no angle measures. So in cases 3 and 4, we're going to use law of cosines. Here's just a quick fact to keep in mind as you're working with oblique triangles. So in any triangles, the sum of the lengths of two sides has to be greater than the last remaining side length. If this isn't true, then you can't actually connect the sides to form a triangle. So this slide talks about how you derive or come up with the law of cosines. Feel free to pause it and read through this. I'm not going to test you on knowing how to derive the law of cosines, but I do want you to just see where it comes from. So here is the law of cosines. So in any triangle ABC, so remember capital letters are reserved for angle values, angle measures, with sides little a, little b, and little c, and those are reserved for side lengths. These are your three versions of the law of cosines. So they're all very, very similar to one another. You just are switching around the variables based on what you know. So if we start with the first one, a squared equals b squared plus c squared, but then you have to subtract this quantity, which is twice b times c times cosine a. And so instead of memorizing all three, you can kind of just recognize the pattern. You have one side squared equals the sum of the other two sides that are squared. And then you subtract twice the product of those two sides, so notice b squared plus c squared, you subtract twice b times c. And then it's the law of cosines, so times cosine, the angle between those two sides. So the angle A is between sides B and C. And so all three of these follow the same pattern. You have a side squared equals the other two sides squared and added, minus twice the product of those sides, times cosine of the angle between them. Now just a quick note, if C is 90 degrees, then if you focus on this third version of the law of cosines, cosine of C would be 0, so this last term would be gone, and it's just the Pythagorean theorem. So for a right triangle, we just have the Pythagorean theorem, which comes straight from this equation. So let's try this example. A surveyor wishes to find the distance between two inaccessible points, A and B, on opposite sides of a lake. While standing at point C, she finds that, notice this is lowercase, so side length B is 259 meters, side length A is 423 meters, and then angle ACB, so remember the angle in the middle is the actual angle you're looking at, so angle ACB is just angle C right here, measures 132 degrees 40 minutes. So the question is to find the distance C. Okay, so we have this drawing here to help you visualize your triangle that you're dealing with. You know this side length B, this side length A, and then you know the angle between those two sides. So this is case 3. This is the side angle side case because the angle we know is between the two sides that we know. So we're going to use our law of cosines because of exactly the given information that we were provided with. So we're going to pick the version based on the angle that we know. We only knew one angle, which was angle measure C. So we have to pick the version of our law of cosines that involves angle C. So this was our third version. And so we fill in our other values. So we actually know all of the values here except little c. So we fill in everything we know. Okay. And so most likely you'll just use your calculator here. After you fill in your values, make sure on your calculator you use enough parentheses And if your calculator doesn't square nicely, you might want to put parentheses around the 423 and the 259 as well. Oh, this is a typo right here. This should be minus. So minus 2 times the product of A times B, and then cosine of your angle. And then also, if your calculator doesn't do minutes, just say 40 over 60. So 40 divided by 60 will turn this into degrees. So you would type in cosine of 132 plus 40 over 60. Okay. So then c squared is this whole quantity. Remember, this should be a minus sign. And then you want c, not c squared, so then you have to take the square root of this 394,510. And so c is about 628. So the distance between the 2 points is about 628 meters. Let's try this example now. Solve the triangle ABC if A is 42.3 degrees, little b is 12.9 meters, and little c is 15.4 meters. So if you don't have a drawing provided, I would recommend just sketching it just so you know which case you have. So I have it written here, side angle side, but let's say you were just given this sentence, solve this triangle. You would want to recognize which case you have. So you would draw side B, side C, and then recognize that side A is over here, so angle A is across from it, and so angle A is the included angle. So you do know a side, another side, and the angle between it. So this is case 3, side angle side. So we're going to go to our law of cosines, and you're going to pick the version that involves angle A because that's the only angle measure you actually are given. So we pick the version of our law of cosines involving angle A, and then we fill in all of our values. So we just plug in our side lengths and our angle measure A, and then we type this into the calculator, and then we want a measure of side A, so you're going to take square root. This is A squared right now, so square root this answer, and you get that A is about 10.47. Okay, so now you do have to still find the 2 missing angles. We know angle A, but we need to know angles B and C, and it does matter which one we pick first. And so what you want to do is you actually want to pick the smaller one, and I'll sum this up a little bit later in the video. You want to recognize out of the 2 remaining angles, which one's smaller. And so you have to look at the side lengths. So side B is 12.9, side C is 15.4, so that means this smaller angle is across from the smaller side here, 12.9. Side C is actually the biggest side out of your 3 sides. This one was 10.4 for A. B is 12.9, so C is the largest side. That means that angle C is actually the biggest angle. So out of the 2 remaining angles, we pick B because it's smaller because it's across from the smaller remaining side. So we're going to solve for B using our law of sines in the very next slide. So B is smaller than C because it's opposite the shorter of the 2 remaining sides. Alright, so we use law of cosines to find missing side length, but now we're actually going to go back and use law of sines, which we learned in the previous section, and that's in order to starting to find the missing angles. So we're going to find the smaller of the 2 remaining missing angles. In this case, it's capital B. So we're going to use our law of sines, and we use our alternate version of it because we're looking for the angle measures, so we can flip over our law of sines and put the angles on top and then the side lengths on bottom. So we fill in the known information. We know everything here except for B, capital B, and then we're going to solve for sine B. So times both sides of this proportion by 12.9, and then we can use sine inverse of this quantity to get B. So B is about 56 degrees. And then we know that angle A is 42.3. We now know B is 56. So then we just use the fact that all 3 angles add up to 180 to find the last angle measure, 81.7 degrees for C. So I was mentioning that why we should pick angle B, the smaller of the 2, and so here's why. Had we used the law of sines to find C, which was the larger of the 2 remaining angles, rather than B, we wouldn't have known whether to pick 81.7 or its supplement 98.3. So if we picked the larger of the 2 angles in this case, we would have been dealing with the situation where we have possibility of 2 angles that give us the same sine value. 81.7 and its supplement would both have the same sine value. So to avoid that, you use the smaller of the two angles. And I'll sum that up in detail a little bit later in this video. In this example, let's solve the triangle if we know side A is 9.47 feet, side B is 15.9 feet, and side C is 21.1 feet. So without even drawing this, hopefully you recognize all of what you're given is side lengths. No angles are given. So this is case 4. This is side, side, side. We don't know any angles, but luckily with our law of cosines, we can find one angle and then we'll use that to continue to find the remaining two. So we're going to use our law of cosines to find the measure of the largest angle. And so you have to look at your side lengths here, and the largest side, which happens to be C, means your largest angle is across from it. So we're going to start by finding angle C. Okay, so we're picking our law of cosines out of the 3 versions that involves angle C. Okay. Again, it's the largest one because it's across from the largest side. So we pick this version of our law of cosines and then fill in all of our values. You can take this step ahead of time if you want. You can solve for cosine C ahead of time before plugging in your numbers. So if you just isolate cosine C by subtracting a squared minus b squared over here, and then dividing everything by this negative 2ab. So that's how you can isolate cosine C. And then you can do that ahead of time before plugging in, or you can just plug in your numbers first if you'd like. We end up getting cosine C is this quantity with our plugged in values. And then using the calculator, this is about negative 0.34. Okay? So cosine C is negative 0.34. So then you can say cosine inverse of this value, negative 0.34, is about 109.9 degrees. Once you have one of the angles, we now go back to using the law of sines. So just like the example before this, we started with the law of cosines, and now we're going to go back and use our law of sines. And we're going to find angle measure B. So we only know one angle so far, it's angle C, so we have to use the ratio involving little c and angle C, and then we're going to find angle B. So notice this is the alternate form of your law of sines, and it's just a little bit easier to work with since we're looking for the angle B. We know the two side lengths, B and C, so it's just slightly easier if we flip over our law of sines and put those in the denominator. So we fill in all of our values that we know, and then we're going to solve for sine B. So times both sides of this quantity, this proportion, by 15.9, and then this is going to help us find B. So take sine inverse of this quantity, and you get that B is 45.1 degrees. And then your last angle, once you know two of them, the last one's easy because you just subtract the two you know from 180. So 180 minus 45.1 minus 109.9 gives us that our last angle A is 25 degrees. Okay, so let's sum up the 4 possible cases that you get when you're dealing with oblique triangles. Cases 1 and 2 are where we talked about the law of sines in the last video. Now, if you know one side and 2 angles, then that's case 1, and then you would follow these steps. So we went through these steps in the previous video. You find the remaining side using the fact that the angles add up to 180, and then you use your law of sines twice to find the missing 2 sides. Case 2 was kind of the tricky one. That was what we call the ambiguous case, and that was because there's possibilities of no triangles with the given information, or 1 or possibly 2 triangles with the given information. So on that one, you want to go through the steps of finding the an angle using the law of sines, find the remaining angle using the fact that the angles add up to 180, and then find the remaining side using your law of sines. But you do have to repeat this if you know you have a second triangle. So in the previous video, we talked about how to figure out if you actually ended up having 2 triangles. It had to do with finding your second possible angle using the law of sines, but you take the supplement of the angle you got from here. So you say 180 minus that angle measure, and then you check if that angle could actually exist. You see if you add up your known angles, if it's less than 180. So we went into detail on that on the previous video. So in this video on the law of cosines, that's cases 3 and 4. So case 3, it's also if you know two sides and an angle, just like case 2, but specifically it's the included angle. So it's the angle between the two sides that you know. You could think of it as like the angle connecting the sides. And so you find the third side using the law of cosines. So step 1 here, you pick the law of cosines that involves the only known angle that you're given. And then you use that to find your last side. Then you find the smaller of the two remaining angles. So this is what I mentioned a little bit on that example. You want to recognize, okay, based on your given sides, which angle is going to be smaller. And the smaller angle is across from the smaller of the two sides, the two remaining sides. And then after you find that, you find the remaining angle just knowing that all three angles add up to 180. And then case 4 is if you know all three sides, but no angle measures are given. So you start on case 4 by finding the largest angle. So you look at all three side lengths that are given. You say, okay, which side is biggest? So my angle across from that is my largest angle. And you find that one using your law of cosines. And then after that, you just find either of the remaining sides, or angles, using your law of sines, and then just find your last angle by adding up to 180. There is an interesting formula toward the end of this section here, and it's called Heron's area formula. So in the previous video, we talked about area formulas for oblique triangles, but this formula is interesting because it doesn't involve knowing any angles. So this is if you know all three side lengths. So you can still figure out the area of a triangle if you only know the three side lengths. So first we want to define this quantity. We're going to call it S, which is called the semi-perimeter. It'll make the calculation look better below. So if you define S to be half of the sum of the three sides, so you add up the three sides, divide by 2. That's what we're calling S. Then the area is the square root of this quantity. S, the semi-perimeter, times S minus one side, A, S minus the other side, B, S minus the last side, C. So you multiply all four of these values, take the square root, and then that is your area. Okay, so we'll try this out. The distance from Los Angeles to New York is 2,451 miles. From New York to Montreal, it's 331 miles. And from Montreal to LA, it's 2,427 miles. What is the area of the triangular region having these three cities as vertices? So just sort of an interesting problem involving city distances. But the question is about the area, so inside of this triangle here. We do know all three side lengths, in this case it's distances, and so we have to use Heron's formula to figure out the area. So start by calculating the semi-perimeter. So it's the sum of the three side lengths divided by 2, so that's 2604.5. And then we plug into our area formula that value of S, and then all three values for our side lengths. And then you can do this all, if your calculator can do it all at once, go ahead and do it all under the square root. If not, you would just multiply these all together, and then after get your answer, and then say square root that answer. And you'll get that this is going to have an area, notice it's square miles, and that's 401,700 square miles.